Hello, fellow knowledge enthusiasts. Ernis here, ready to embark on another thrilling adventure in the vast cosmos of academic discovery. Today, we're diving deep into a fascinating paper titled, Thinking with Video, Video Generation as a Promising Multimodal Reasoning Paradigm. Sounds intriguing, right? This paper comes to us from some brilliant minds, including Jingqi Tong, Yurong Mo, and many more from Fudan University, Shanghai Innovation Institute, and beyond. They've tackled a really interesting problem: how can we make AI reason better, especially when dealing with both images and text? Now, before we jump in, imagine you're an AI. You're great with words, and you're pretty good at recognizing objects in pictures. But what if you need to understand something dynamic, something that changes over time? Like, say, predicting where a ball will land after it bounces. Or explaining a complex mathematical equation using both diagrams and text. Current AI systems struggle with this because they often treat text and images as separate entities. That's where thinking with video comes in. The core idea is this: instead of just using static images, let's use video generation models to create dynamic visual representations that AI can then reason about. Think of it as giving AI the power to imagine and visualize scenarios. All right. Let's step into our memory palace. Picture a sprawling art gallery, each room dedicated to a different aspect of this research. In the first room, we encounter the problem itself. Imagine a room filled with scattered photographs, snapshots of isolated moments. These represent how current AI often sees the world, disconnected and static. Now, imagine a film reel suddenly bursting to life, connecting those moments into a fluid narrative. That's the power of video. Next, we enter a brightly lit studio. Here, the researchers introduce their key innovation: leveraging video generation models, like the impressive SOR, to bridge visual and textual reasoning. SORA, for those not in the know, is a cutting-edge AI that can generate realistic and imaginative videos from text prompts. The researchers propose using SORA to create videos that illustrate the reasoning process itself. Think about it. You could give SORA a math problem and ask it to create a video showing the step-by-step solution, complete with equations and diagrams appearing on screen. Or, you could give it a spatial reasoning puzzle and ask it to draw lines and shapes to find the answer. To test their idea, the researchers built something called the Video Thinking Benchmark, or VIDE. Catchy, right? This benchmark includes two main categories of tasks: vision-centric and text-centric. Let's teleport to another part of our memory palace. We find ourselves in a game room filled with puzzles and challenges. In one corner, there are eyeballing puzzles, where SOR has to estimate geometric properties, like finding the midpoint between 2 points. In another corner, there are mazes, where SOR has to draw a path from start to finish without hitting the walls. The paper demonstrates that SORA does surprisingly well on these vision-centric tasks, even outperforming some existing VLMs. And, in yet another room, we find a library overflowing with books and equations. Here, the text-centric tasks come into play. These include subsets of well-known benchmarks like GSM-8K, math word problems, and MMMU. A multi-discipline benchmark. The results? SORA achieves impressive accuracy on these tasks, demonstrating its ability to reason about text and generate videos that explain the solutions. Now, you might be wondering, okay, Ernis, that's cool and all, but where does this power come from? Well, the researchers dug into that too. They found that techniques like self-consistency, where the model generates multiple videos and chooses the most consistent answer, and in-context learning, where the model learns from a few examples, can further improve SOR's performance. But perhaps the most fascinating finding is this: the researchers speculate that SORA's text-centric reasoning ability might stem from an internal prompt rewriter model. This model essentially translates the text prompt into a series of visual instructions, making it easier for the video generation component to create a meaningful and accurate video. Fine, yeah, I guess. Look, the point is, this paper is a big deal. It suggests that video generation models are not just fancy image generators. They are potential unified multimodal understanding and generation models. By enabling AI to think with video, we can unlock new levels of reasoning ability and create systems that can truly understand and interact with the dynamic world around us. So, what does this all mean for you, the curious listener? Well, it means that the future of AI is bright, and it's filled with moving pictures. Keep an eye on video generation models like SORA. They're not just about creating cool visual effects. They're about building AI that can reason, imagine, and solve problems in ways we never thought possible. This is just one small step for AI. But it's a giant leap for our understanding of intelligence itself. Until next time, keep exploring, keep questioning, and keep your minds open to the infinite possibilities of the cosmos and the world of research.